you do this question, then we'll come to the second topic questions. This 31st and 32nd. We can discuss this question only of this topic. An object experiences a net zero unbalanced force. Is it possible for the object to be moving with a non-zero velocity?
Is it yes?
And state the condition. Yes, Aram.
I don't. It's not no. I know that.
It's not no, but it will be yes. But you don't know what would be the condition, right?
I don't know what.
And Razi, what do you think?
Ma'am, I also think yes.
So what is the condition?
Ma'am, it's because of it's unbalanced force.
Yeah, unbalanced force.
No, it means a force is applying greatly in another direction.
Can it be like a body can move if a body is moving in a circular path with a constant velocity v something, then it's remain to move in this circular track only. It will be a net and zero unbalanced force. Its direction will be of inside the center, right? Magnitude will be the constant.
Ma'am, my internet got disconnected.
What happened, Shazan?
Ma'am, internet got disconnected.
Okay. Razi, can you please switch on your camera? And Sharia, can you please switch on your camera?
I'm on my mobile phone, and it is hard to like. I don't have a mobile stand, so it's hard to make a mobile play them.
Okay. Okay, Shazan, can you tell me this 31st question?
Yes. Ma'am, net zero unbalanced force means?
There must be unbalanced force and it must be net zero. Should be zero. Means like it must not be changed. It must not be changed, and the object must be having some velocity.
Ma'am, goal of gravity?
Gravity?
Yes, ma'am, because goal of gravity is always there and the velocity is 9.8 meters per second.
But there is also some kind of air resistance.
Yes, ma'am, there is air resistance.
Even the air resistance will be work as a force.
Gravity is non-zero unbalanced force, ma'am, because it's also means the object experience zero. It does not move from one place to another, but ma'am, but object doesn't move, but it is means the force is acting on it, like gravity.
And it will be a non-zero velocity, but it will be the velocity will keep on changing, right? At every point, the velocity will keep on changing.
Yes, ma'am, it's 9.8 meters per second squared.
That's what I thought.
There will be a continuous acceleration that will be
Yes, ma'am, there will be acceleration.
body. So can it be this body moving in a circular path having fixed v velocity, and its direction will be off towards the center. It will
Ma'am,
be
Earth rotating on its axis.
non-zero velocity, and it will be exerting zero unbalanced. Hello, Sharia, are you there? Or she left? Okay. So for 32nd question, can you draw velocity time and displacement time graph for a moving object on which no net unbalanced force is acting? This will be like this: velocity time graph, displacement time graph. Velocity time graph will be as such. Velocity is being the same throughout, right? Velocity time graph. For a moving object, it's the object is moving also, right, with some velocity, and it's constant, in which no net unbalanced force is acting. Here, no force is acting because its velocity is not changing, right? Its velocity is not changing, and this will be the velocity time graph. And for displacement time graph, it will be like this.
Ma'am, the answer is velocity time graph or displacement time graph.
Yeah, we have to draw a velocity time graph and displacement time graph for a moving object. The object must be moving, and no net unbalanced force must be acting on it. Means there should be velocity should be what? Velocity should be what? It must be using this thing. F is equal to ma. So m v minus u by t. If f will be 0, this will be 0, then v will be equal to u, right? Then v will be equal to u. Means v and u, it means the motion is what? Uniform. The motion must be uniform. And your displacement time graph, right? It is for uniform motion, no? This graph is for uniform motion. This graph shows the uniform motion. So this will be the distance time graph for this force being zero net unbalanced force, and for this will be the velocity time graph where v will be something, v will be non-zero, and also it will not be changing. Why? Because v must be equal to u, means v must not be changed because f is zero. F is zero. When f will be zero, then v is equal to u. Okay. So these are the questions that are theoretical. And then we were on the Newton's second law of motion. We were to do some of the examples, right? We did up to this application of Newton's second law of motion. We have to start from this. Newton's first law from mathematical expression of second law. Newton's first law from mathematical expression of second law.
Can you just do the left part again?
Yes.
Proving part again.
Yes, yes.
Can you do the proving part again, which is in the right side, ma'am, and in orange color?
Which part? This part.
Yes, ma'am.
What we were doing in this?
Ma'am, I forgot.
What we were doing in this? Arham was saying something about it, no? He was deriving something.
Yes, well, I was, but I got a little wrong.
I haven't remember this point exactly what we were discussing here. Okay. So Newton's first law from mathematical expression of second law. Now we are knowing that for second law f is equal to
MA.
Okay, MA, and for f is equal to MA, M will be what? V minus U by T. Okay, we can take T here. Okay, we can take T here, and then we can multiply this MV minus MU. Now for f is equal to 0, if we are to apply first law of motion, then what is the first law of motion? An object will tend to remain at rest if it is in rest, and if an object will tend to remain in motion if it is in motion, until unless an external force is applied. Suppose here no force is, suppose there here f is equal to 0, no net force is getting applied. Okay, so we'll see here if f is equal to 0, we'll see 0 is equal to mv minus mu. It means mv is equal to mu if m and m will get cancelled, and then we'll see if v is equal to u. If v will be 0, if u is 0, if u will be 0, then v will be 0. Means if a body is not moving, then the body will remain at rest if until unless
Another force is applied.
And if a body is moving with some velocity u, suppose 50 meter per second, then what will happen? U will also be 50 meter per second, because from this expression we are getting v is equal to u. Whatever be the value of u will be the value of v. Okay. So v is equal to u. If u will be 0, if initially the body is at rest, with u is equal to 0, then it will be remained at rest if f is 0. No, if force is not getting applied. Okay, and also if a body is moving with some velocity, then it will remain to move in that velocity only until unless force is getting applied. Okay, so from second law of motion we have derived what? First law of motion. We have this Newton's first law of motion. Okay, why are you playing hide and seek, Shazam?
Ma'am, I'm getting disconnected.
Okay, now it's time to do some numericals. Force acts on an object of mass 4 kg and changes its velocity from 10 meter per second to 20 meter per second. Find the magnitude of force. This is our question.
Ma'am, can you zoom into the question? It's very small.
Force acts on an, is it visible now? Force acts on an object of mass 4 kg. First write the given 4 kg. Its velocity is changed.
U is given 10 meter per second.
10 meter per second, and V is given as
V is given 20 meter per second.
And time is given as 5 seconds. Try to write it in one line. I have written in this, means in a column wise. Okay, in a different line. It will be more systematic. Find the magnitude of force. So we have to find force. F is equal to ma. Now first we have to find what?
Ma'am, we'll write. Okay, acceleration.
We have to find F. Okay, so do this question. To first find A, just you need to put it in the formula. Everything is given, V is given, U is given, T is given, A can be found, and then when A is got calculated, then we can find F. Razi, do this question, and Sharia, do this.
Acceleration is 2 meter per second square.
Acceleration is 2 meter per second square. Okay. And always keep in mind about this what
Units.
units. Yes, units. It may be given in the question like in kilometer per hour. Some I mean like one velocity in
Force
kilometer.
is 10 Newton.
Force is 10 Newton or 8 Newton.
Ma'am, it's 10 Newton because so M is equal to 4 kg, already 5 kg.
Yes, ma'am. Ma'am, force equal
8
to 10
newtons.
Newton. Sorry,
10
ma'am, 8 Newton.
8 Newton. Arham, what is your
One more numerical.
what is yours?
The acceleration is equal to 2 meters per second. Squared.
Square.
Okay, so what is your force?
Ma'am, what was the mass game?
Hmm?
Ma'am, could you show the question again? The earlier question.
Yes.
What was the earlier question?
Wait. Just wait. This is
Well, I got x is equal to 16.
16.
Yes, ma'am. Sorry.
In the square. Have you done the square? You have got A as 2. You have M as 4. F is equal to 16. The product of M and A. So what you'll get? 4 2s are.
No, it become 16.
Why are you getting 16, Aram? Have you got A as 2?
Yes.
A as 2.
How to do this question?
Oh, M is 4. Okay. I thought M was 8. Okay.
Oh, someone is taking as 5. Someone is taking as 8. What's going
No,
on?
it's equal to 8.
If these mistakes you'll do here, then what you'll do in exams and tests. So this question, force is given as 50 Newton.
Mass is 10 kg, time is 2 seconds.
Given as 10 kg, and then time is given as 2 seconds. Find the acceleration produced. First, we have to find acceleration, and then we have to find velocity attained by. On a stationary body, it means already u is given as
0.
0 meter per second. So everything is given. So first we have to find A from the formula. F is equal to
Ma'am,
M.
A is equal to V by U by T.
Okay, F is equal to MA. So we can find A as F by M. Find out.
F by M. M is 5.
F by M as 5. Okay, you have got it. 5 meter per second square.
Yes, ma'am.
And then you have to find V. So for V, we have already have A is equal to V minus U by T. Time is given. A we have already calculated. A T plus U. It will be
A is equal to 5 by 2, I guess.
yes.
Ma'am,
5
He said A is equal to 5 by 2. He said.
5 by 2.
Yes, sir. Answer. I did not, sir.
5 by 2. How?
ma'am, if force is given and mass is given, acceleration is not given. So, ma'am, 50 Newton is equal to 10 kg into A, and then 50.
What is it? Simple division and multiplication.
So, ma'am, I got 20 kg instead of 10.
Means you will do the questions wrong knowingly. Razi, what you got?
Acceleration.
What your specs? Yes, acceleration is equal to 5. You got it, Razi?
Yes, ma'am. 5. Yes, ma'am. 5.
Now
5
find
meter per second square.
E, find B. U is equal to 80. U is equal to 80. Yeah, sorry, U plus 80. V is equal to, so U you have got 0 and A you have got 5. T you have got as 2. 10 meter per second. Will it be?
10 meter per second. Yes, ma'am. 10 meter per second.
Yes. Now, Shazan, you must have had got 20 after wearing specs. Isn't it?
Yes, ma'am.
Yes.
Yes, ma'am. A is 5 meter per second minus 1.
Getting what I'm doing here?
Yes, ma'am.
What you're getting? Does
Ma'am,
you
you are
get
converting kilometer per. Yes, ma'am. You are converting kilometer per hour to meter per second.
and this is given as U or V? How can you infer whether V is given or A is given? How can you infer from the question?
Ma'am, as time is given in seconds, so I will turn the initial velocity or velocity in meter per second.
No, I'm not asking ki we have to convert it into meter per second or not. It's obvious if the time is given in second and everything is given in second, then we must have to change it in meter per second because it's the standard unit, right? I'm asking whether how can I infer whether U is given or V is given. initial velocity is given or final velocity is given? How can we know this thing from the question?
Ma'am, if the question
Ma'am,
doesn't say anything about
after the brakes is applied, ma'am, then the velocity changes, and when the velocity changes after the brakes applied, ma'am, that will be the final velocity, and the initial velocity is 180 kilometer per hour.
Okay, and Arham, how do you find that?
what was the question again?
What's the question again? I already have said it so many times. How can you infer from the question whether initial velocity is given or final velocity is given?
Ma'am, if it's like it's saying it's already moving and then it happens something like it takes 5 seconds to stop or something, that means its initial velocity is there. But if like and there's nothing else, that means final velocity is unknown and initial velocity is there. But if it's like its initial velocity is like it's not telling anything about the initial velocity, but it's after like it's like taken 5 seconds to stop or something, then it will and it will give the velocity, then it's the final velocity.
Okay, means in the starting if the velocity is given and any brake is getting applied and after it has got stopped, after some time it has got stopped, then the means the thing that is given as a stopped, it means that it's given as V. The body is getting stopped after traveling some distance, after traveling few minutes or time, now a few seconds. Okay, then V is given and initially U is given here. Means initially with what velocity it was moving, here it's U is given. Okay, and if it's given in the question like a body has started from a means a stationary body has just started, right, and attained some velocity, then what? U will be 0 and V will be the given. Okay, so here U is given as 180 kilometer per hour, and here it's everything is in the standard unit in second and kg. So we'll convert this 180 kilometer per hour to meter per second. Okay, and then here T is given as 5 seconds. To stop, it means V is given as 0 after brakes are applied. Find the force exerted, if we have to find by the brakes on the wheel of the train with the mass with the wagon is 2000 kg. Here you are given mass as 2000 kg. Okay, we have to find V first. How we can find V?
Ma'am, V square minus A square equal to AS. No, not. Ma'am, V equal to U plus 80.
V is equal to U plus 80. We can apply that. V is equal to U plus.
Ma'am, A is not given.
A is not given. Yes, A is not given. After the brakes are applied.
Ma'am, how to find A?
V is given and U is given.
Ma'am, V is not given.
V is not given. V is given as 0 now.
Oh, okay. Okay.
V is given as 0.
First you find the acceleration.
We can find A first and then F. First we have to find A and then
Ma'am, A is minus 25 meter per second square.
minus 25. Minus 25. 50 by 5.
No, ma'am, it is V minus U.
So 0 minus 50.
0 minus 50 is minus 50.
Minus 50 by 5. Will it be 25?
Okay, I thought it's no. I thought it's 2 seconds. Okay, 10.
Every time you are making mistakes.
Ma'am, acceleration is minus 10 meter per second square.
Yes, acceleration is minus 10 meter per second square. And then force,
It's 20,000 Newton. Minus 20,000.
minus 20,000 Newton. Does you have got it? Aram, you have got it?
Yes, ma'am. Yes,
Sharia,
ma'am.
have you got it? Sharia, have you got it? What more examples? Just these examples.
Understand? I'll not do mistake.
Hopefully, a force of 6 Newton gives a mass m1 and acceleration of 18 meter per second square. This question is seems to be quite
I will try.
very tricky, but it will be
Yes,
something like this.
it is tricky.
Newton gives a mass m1 and acceleration means force of 6 Newton is giving first let me write the question. Okay, we can discuss it here also. It's given. Force is equal to 6 Newton gives mass m1 So m1 giving mass m1 acceleration as 18 meter per second square. Okay, and mass m2 as 24 meter per second square acceleration. What acceleration would it give if both the masses were tied together? If both the masses were tied together, then what would be the acceleration? First, we have to find all of find the masses of both of them, right? Because force is given and acceleration is given. We can easily find masses m1 and m2. Okay, so we can find m1 and m1 like f by a. Okay, so f by a1. So here m1 is given. M1 and m2 has been calculated as 1 by 3 and 1 by 4. 6 f by a1. There's force is getting force is remaining constant for both of them. 6 Newton. 6 by 18 and then 6 by 24. So for one, we will get 1 by 3 kg mass, and for second, we will get 1 by 4 kg mass. Now these masses are getting tied together, right? So means 1 by 3 plus 1 by 4. So what we will get? We will get 7 by 12 kg. These both masses are getting tied together. Now it's asking what acceleration would it give if both the masses were tied together? Means force again is remaining the constant. Acceleration we have to find. F is equal A is equal to F by M. Now M we have got as 7 by 12 and F we have got already as 6 and 7 by 12. So 12 will go.
It's asking the total force.
It's asking acceleration.
What to find in the question?
Force is remaining the same. Mass has got tied together to make up 7 by 12 kg. We have to find acceleration. Now 12 will go to the numerator and 7 will go to the denominator of 6. So it will be 6 into 12 by 7. What it will be? It will be like 10.28 meter per second square. So have you got it how to solve this question? First we have to find masses individually, right?
A is equal to 7 by 2 meter per second square.
Yes.
A is 7 by 2 meter per second square.
A is 7 by 2. What you said?
What is acceleration?
No, not 7 by 2. 12 will, here this 6 is in the numerator and the denominator of this is 1. This will 12 will go to the numerator means 6. 12 into 6 by 7. Razi, have you got this question? Razi?
No, ma'am, can you explain me the mass part?
Mass part. So it's given in the question that 6 Newton force is giving the mass m1 acceleration of 18 meter per second square means m is equal to 6. Okay, and it's giving mass a1 as 18 meter per second square. We have to find m1. What will be that? M1 will be f by a1. Yes or no?
Yes, ma'am.
Yes or
Yes, ma'am.
So 6 by 18. It means that it will be 1 by 3.
Oh, yes, ma'am. Now I get it.
1 by 3 kg, and for second m2 will be f by a2. Okay,
Yes, ma'am.
a is given as 6 and a2 is given as 24, so it will be 1 by 4 kg.
Yes, ma'am. I got it.
Okay, now next question. The velocity time graph of a ball of mass 30 gram. The velocity time graph of a ball of mass 30 gram moving along a straight line on a long table is given below. Graph is given below. No? This graph. Velocity time graph of mass 30 gram moving along a straight line on a long table is given below. How much force does the table exert on a ball to bring it to rest? What it's saying, bring it to rest. It means that V will be equal to 0. M is given as 30 gram. Okay. How much force? And V is equal to 0. And here we have got as U as, how much we are getting U as? 30? Is it 30? This is 30? 30 centimeter per second. It's given as centimeter per second. We have to convert it
to meters per second.
Meter per second. So how can we convert it? We can divide it by 100. Just 100 because second is already there. Okay. Only we have to convert centimeter to meter. So we will divide it by 100. So we will get 0.3 meter per second. U. Okay. And what we have to draw? We have to draw F. How much force? And time is given as, from this graph, we can know the time is given as 6 seconds. Okay. Time is given as 6 seconds. So T is given as 6 seconds. A we can know V minus U by T, which is V is how much? 0 and U is how much? 0.3 upon T. T is 6. So V 0.3 by 6. What will be the 0.05, I guess, minus 0.05 meter per second square. Will it be this or not? 0.05? Yes. So 0.05 meter per second square, and then we'll get, yeah, this we have got as A. F is equal to MA. M is what? 30 30 gram, and we can convert it in how much? In what? In kilogram as 1000 upon 1000. So 1 upon 1000 into 30 into minus 0.05. So what we can get here, minus 0.5 into 3 upon 1000. So we can get it as minus 1.5 upon 1000. Minus 1.5 into 10 power minus 3 Newton, right? Minus 1.5 into 10 power 3 minus 3 Newton. Oh, sorry, minus 3. Yes, minus 3 Newton. This will be our force. Have you got this? How I have calculated? I've just seen this graph, and here time is given. Here you have got as u, because this graph is getting started from here. So we'll get this thing as u. So u will be 30 centimeters per second. So it will convert this as meter per second, which will be 0.3 meter per second. And then t will be 6 seconds. It's already given here. And then v is 0, as already given in the question. Bring it to rest. So it's already given in the question that v is equal to 0. So everything we have got it. M as 30 gram. And then we'll find a. After finding a, what we'll do? We'll find f. And for f also, we are having here 30 gram. This we have to consider it, that it's given in grams. So we have to convert it in kilogram upon 1000. So it will be upon 1000, and we'll calculate it, and we'll get as minus 1.5 into 10 power minus 3. Okay.
Okay.
So I will be sending the PDF of this, and then this what assignment has already been assigned, I guess. Okay, this you have to complete it, and once in any question, if you are getting problem, just send me the question.